In this video, we're talking about similar figures. Now, for some of you, this might be reviewed, but I would think for the majority of you, this is probably new stuff. So definitely pay attention to this, because after we finish this video, we're going to go in more detail about similar triangles. So, when there's a correspondence between two polygons such that the corresponding angles are congruent, so the angles are congruent and the lengths of the corresponding sides are proportional, then the two polygons are similar. So, it works for triangles, squares, pentagons, or just regular quadrilaterals. Pretty much as long as you got a polygon, as long as the angles are congruent and the side lengths are proportional, then these two figures are similar. And what similar kind of means is the same shape, but not necessarily the same size. Okay, so same shape only. So in example 24 in this diagram, quadrilateral ABCD is similar to quadrilateral EFGH. Again, because all the angles, corresponding angles, are congruent. Corresponding angles are congruent. Also, the sides are proportional. So AB matches up with EF, that's proportional to BC, which matches up with FG. So this proportion is true for all pairs of sides. If two polygons are similar, then the ratio of the lengths of the two corresponding sides is called the scale factor. Okay, so when you find this proportion, this proportion for the ratio, I should say, of the corresponding sides of AB compared to EF, that is going to be called the scale factor if we actually had numbers in it. So for instance, we might say that quadrilateral ABCD is 2 times the size of quadrilateral EFGH. So, and if two polygons are similar, then the ratio of their perimeters, again, perimeter just means add up all the sides, is equal to the ratio of their corresponding side lengths. So in this example, I have quadrilateral KLMN is similar, this little squiggle mark means similar, to PQRS. Then I'm going to find the perimeter of the first quadrilateral, so KL plus LM plus NM plus NK, and that goes on top, because that's the first quadrilateral, divided by the perimeter of PQ plus QR plus RS plus SP, that's the perimeter of the second quadrilateral. This makes a ratio that's equal to the ratio of the corresponding sides. For instance, if I want to compare it to KL and PQ, these two fractions would be exactly equal. Okay, the corresponding fractions are equal to the perimeter. All right, so we have an example 25. In the diagram, we have triangle BTW is similar. Again, this symbol means similar to triangle ETC. We want to write the statement of proportionality. All right, in part A. Part B, we want to find the measure of angle TEC. And part C, we want to find the length of ET and the length of BE. Let's start with part A. Let's write the statement of proportionality. Well, we're going to start off with angle B is congruent to angle E. We're just paying attention to the order of the letters. Again, when it's similar, angles are congruent, sides are proportional. So angle B is congruent to angle E. Angle T is congruent to angle T. And then angle W is congruent to angle C. I'm just following the letters. Alright, so now we're going to do the same thing with side lengths, but since it's similar, the side lengths are proportional. So, for instance, BT over ET, that's a first and second, that's going to be equal to TW over TC, second and third, and that's going to be equal to BW over EC. First and third, okay? Angles are congruent, the corresponding side lengths are proportional. Alright, now we want to use this information to find the measure of angle TEC. So I'm going to do part B in blue. So angle TEC is this angle right here. That's the one we're trying to find. So we're trying to find angle E. Well, based on this, angle E is congruent to angle B. Well, angle B is 79 degrees. Angle B is 79 degrees, so that means the measure of angle TBC is also 79 degrees. All right, that was pretty easy. And then finally, in part C, we want to find ET and BE. So ET and BE. All right, well, ET is this side right here, and BE is this side right here. We know the total length is 20. All right, so let's set up our proportion with what we know. We know BW, so I'm going to use this fraction, and EC. We know both of those, so I have BW is 12. So let's do this in yellow. So I have 12 over 3 is equal to, now I want to use these two parts. Let's see, BT, the total length, which I know, so 20 over the partial length, ET, the little triangle. So let's plug that in. ET is the missing piece that I want to find. Just to make things look a little nicer, instead of ET, I'm going to say that's equal to X. All right. So again, I'm going to call ET is X. That's what I'm solving for. All right, well, again, I have my proportions set up now. So what I'm going to do is flip each fraction because my variable is on the bottom. So I have 3 over 12 is equal to X over 20. Now, like we've done in the previous videos, we want to cross multiply. So I have 3 times 20 is equal to 12 times X. Well, 3 times 20 is 60. And what I'm going to do now is divide by 12 on each side. So this means that X equals 5. So since X equals 5, that means ET equals 5. And I'm going to go ahead and plug that in my picture. So ET was right here, so I have 5. But since I know that the total length is 20, and now that I know this little piece is 5, I can now find BE. So BE is going to be 20 minus 5, which is 15. So again, as you find the information in your picture, you want to plug it in because it's like a jigsaw puzzle. The more pieces you put in, the easier it gets to solve. And we've done every single part. Part A, we just wrote the similarity statement. Part B was pretty easy because the angles are congruent. And part C, we just used the proportion that we made in part A. Plugged in and subbed in cross multiplication. Not too bad. All right, and we know that the two angles of one triangle are congruent to two angles of another triangle, then the two angles are similar. So for triangles, and this only works for triangles, if we have two angles are congruent to two angles of the other triangle, and that's all we know, then automatically we can say that these two triangles are similar. We would need more information to say that the two triangles are congruent. But all we need to say similar is just two angles. So in example 26, we want to find the length of altitude QS. All right, we want to find the length of altitude QS. So QS is what we're trying to find. I'm going to highlight that in red. This is the piece I need. Okay, that's what I want to know. All right, well, let's look at what we've got. I know that vertical angles are congruent. So these two angles are congruent, which means that since the altitude is kind of splitting, I don't know if it's bisecting perfectly, but since the altitude is cutting these angles into pieces, I have an angle and an angle. These two angles should be angle and an angle. So triangle NMQ should be similar to triangle RSQ. Those two triangles should be similar. Based on what we said, if we know two angles are congruent, the right angles are obviously congruent, and then these two angles are congruent, then the two triangles should be congruent. Or should be similar, I should say. So triangle MNQ is similar to triangle RSQ. Sorry, I should say SRQ, because the order does matter. So here, angle M has the 90 degrees, angle S has a 90 degrees. So let's go ahead and write out our similarity statement. So angle M is congruent to angle S. Angle N is congruent to angle R. And then angle Q is obviously congruent to angle Q. We also know that corresponding sides are proportional, so MN over SR is equal to NQ over RQ, which is equal to MQ over SQ. All right, so I wrote my similarity statement. Also, since these two triangles are similar, it kind of makes sense that these two triangles are similar. So I'm going to write that similarity statement as well. Okay, so I'm going to need some extra room. So I have triangle MPQ is similar to triangle STQ. And I know that angle M is congruent to angle S. Angle P is congruent to angle T. And then angle Q is still obviously congruent to itself. Well, again, the corresponding sides match up. So we have MP over ST is equal to PQ over TQ. And then finally, MQ all over SQ. All right, so I have everything set up. Now what I want to do is find the length of QS. So I want to use the ratio that has QS, which is this one right here, and I want to plug in what I know. Well, QS is what I'm trying to find, so I'm looking for MQ. Let's find it. MQ is right here, so that's 6. So I have 6 over QS is equal to, all right, now, NQ and RQ. Let's see, do I have RQ? Nope, I don't have that. NQ, I don't have that. So let's go to something else. I have MN, which is 12, over RS, which is 8. Okay, so now I have everything I need. Instead of QS, I'm going to call QS equals X temporarily. So I'm going to put an X here just so it looks a little bit nicer. And now I want to solve this proportion. To start off with, I don't like having the variable on the bottom, so I'm going to flip both fractions. So I have X over 6 equals 8 over 12. And now I'm going to cross multiply. So what we have is 12x equals 6 times 8. So 12x equals 48. And now I'm going to divide by 12 on both sides. So x equals 48 divided by 12, which should be 4. Okay, you can always double check that on your own. But remember, I made a rule that said x is QS. So that's 4. That was what I was asked to find. So QS is 4. That's what I was asked to find, so I'm done with this problem. So yeah, I wrote the similarity statement for the other triangle. It's because I didn't know which information I needed, so I went ahead and did both, okay? Didn't need any of this. I was able to just stop here. That's okay. I did a little bit extra work. That's it for this video. If you got questions, let me know.